Welcome back everyone. Today's video is going to be a short coding tutorial on how to check transactions to a certain address on Ethereum through the Web3.js library. Web3.js is the JavaScript API for interacting with the network, and it can do some pretty cool stuff. But in some ways it's also pretty limited. So this is how it works. You have a web application written in Node.js, perhaps an Ethereum wallet or something. And this app needs to interact with the Ethereum network. You would use the Web3.js library, which then provides you with an API to do all sorts of cool stuff on Ethereum with Node.js, like create a contract, send a transaction, get the current block, and so on. Now this is a simplified drawing, and in reality we need an Ethereum node as well, like Infura or Geth. I'm going to use Infura since they offer free Ethereum nodes to anyone that wants them, as long as you don't go over their request limit. I suggest you use an Infura node as well. So just create an account, log yourself in, create a new project, and then you should see this dashboard. You can click on View Project and then go ahead and copy the project ID, because we're gonna need it for authentication later. So I had the idea for this video because I've recently encountered a problem in a new project that I'm working on, where I had to check in real time the transactions to a given address. I looked around the internet on how to do it and couldn't really find any good ways, so I've tried to come up with my own solutions. Two different scripts came out of this, one very CPU and network intensive one, making it pretty slow, and another one that was way more simple and which I haven't really seen around. So I'm gonna go over both of them and try to explain every step to you. Okay, so the way the first script works is we retrieve the latest block through Web3.js, then we loop over all the transactions in that block, and if the receiver field of a given transaction is the address we're monitoring, we're gonna check the value and where it's from. Alright, so I've created a new directory. All I've got is this markdown file. And since we'll be needing node packages, we'll just do npm init. I'm just gonna go over this real quick. It doesn't matter. Alright. And the first package, actually the only package we're gonna need is Web3. So let's install that. Now this is gonna give me a bunch of errors, but they don't really matter, so I'm just gonna let this run for a while. And in the meantime, I can already create a new file. I'll call this one transaction checker.js. Alright, yeah, here's all the errors, but it doesn't matter. Okay, so I'm gonna close that. Now, a little disclaimer, I'm gonna be programming in JavaScript. I will be using JavaScript ES6 syntax, and we'll also be putting all our functionality into a class because I find that to be more accessible. Alright, so the first step is to import Web3. Require Web3. Alright, and then we're gonna create a class. I'm gonna call it transaction checker. And our class is going to have two properties. The first one is Web3, and the second one is account. And account is going to be the account we want to monitor. Then in the constructor, which gets called if we create a new instance of the class, we have two parameters. The project ID, which is the Infura project ID I've told you to copy because we're going to need it for authentication. And then the account again. Alright, we'll now initialize our Web3 instance using our Infura Ethereum node as a provider. Now the way you do this is like this. So this.web3 equals new web3, and this takes in a provider, so we have to create a new provider. Web3.providers. We'll use an HTTP provider. And then we need the link to our project. So HTTPS, yeah, so I will use the testnet, Rinkeby testnet, and not the mainnet, because otherwise I'm gonna have to show you how this works with real money, which I don't have at the moment. So v3, and then we concatenate that with our project ID. Alright, great. And then we have to initialize our account. And we'll do some safety checks, mainly do the account string will lowercase everything, so we can check for equality with more assurance. Now the first and actually only method of this function is going to be check block, which will be an asynchronous function since we'll be using async await. So check block. Alright, and firstly we want the latest block, and this is how to do it. So let block equals await this dot web3 dot eat, which is the Ethereum API, and then get block, and this takes in a number, a block hash or a number or a string, and I'm going to use latest, which will just return the latest block. Now this will return a block, and a block looks like this. So we have the difficulty and all the properties of a block, and the important ones are number and transactions, which are transaction hashes, a list of transaction hashes. Okay, so we've got that done. Yeah, and for convenience, we're just gonna store the block number in a different variable number. Oh. Okay, and then we'll do some logging. So console.log searching block plus number. This will just tell us in what block we're currently looking. Alright, and then we're gonna have an if statement. So if block is not null, just some checks, and there were transactions in the block, so block.transactions is not null, then we'll go over all those transactions which are stored as transactions hashes in a list. So as you can see, here they are. We'll just loop over them with a for off loop. So for let transaction hash of block dot transactions, and then we'll just as we did last time, we'll get the actual transaction. So let transaction equals await this dot web3 dot eat dot get transaction, and this takes in a transaction hash, and again this returns us an object which looks like this. So we have the block hash where it's in, and then a from address, then the to address, which is of course important, and then the value, which is in way, and way is, I think, no, it's not, yeah, I think it could be the smallest unit of ether. Right, so we got that done, and then we'll check if the account that is the receiver of the transaction equals the account we want to check for. So if this dot account equals transaction dot to, which is how the field is called, the receiver field, dot to lowercase, again to be safe, and if that's the case, we'll console.log that we have a transaction found on a block, and then the number, and we'll do some additional logging. Let's say in an object, so address, which will be the address that was the sender, is transaction.from, then value equals, yeah, so since the value is in way, we want to convert that, and this can easily be done with another API that Web3 provides, which is called the utils API. So this is web3.utils, and the function is called from way. First argument is the number in way, and then the string of the currency we want to convert it to, and then just for logging's sake, we'll do a timestamp, so the current date. Okay, so that was how our class looks. Now we'll create a new instance of the class. So let transaction checker equals new transaction checker, and the first argument was the project ID, and since since my Infura project ID is in the environment variables, I'm gonna call it like this, so process.env.infura ID. And then the account we want to look for is gonna be my account. Just a second. I have to copy it over. Okay, great. And then the function we want to call is transaction checker dot check block. All right, nice. Let's see if this works. I hope it does. So node transaction checker.js. Yeah. So it was searching block 5,359,831. Let's see if it's incremented. Yeah, it did. All right. Now the reason this script isn't very good is because you're relying on the block times. No, wait, I'm going to explain this in a different way. So the Ethereum block times are on average 15 seconds. So every 15 seconds a new block is mined. But this is an average, so there can be outliers. If we do, for example, if we check every 15 seconds, there is a pretty high probability that we miss a block. So 15 seconds, that's 15 times 1,000 milliseconds. All right, so let's see what this gives when we check the block every 15 seconds. Node transaction checker.js. There might be some errors in here because of the Rinkeby network, but I should be able to test this just fine. So every 15 seconds is gonna retrieve retrieve a new block. And all right, right now it's checking number 53, and of course we're hoping we don't skip any blocks. Now you can see the problem with this is that we're relying on the average Ethereum block time of 15 seconds. So this means, okay, here we got an error. Which means that every 15 seconds a new block is mined. Of course, these are statistical averages and there can be outliers. There have been block times known of like, I don't know, 2 seconds. Here you can see we skipped the block, so this isn't safe. Now, of course, you can decrease the interval time, but this will increase the load on both the network and your computer resources. So this is not an ideal script. Alright, so version 2 is going to be a little different in that we're going to use something provided by the Ethereum network called a publisher. So as a subscriber, we can subscribe to certain topics, and there happens to be a topic called pending transactions. Pending transactions are transactions that have just been sent out and haven't been confirmed yet, so they haven't been verified and included in a block. Now all sorts of events get broadcasted to the network by said publisher, and then of course we can choose the topic we want to subscribe to. Now if a pending transaction is sent out, we get the transaction hash of that pending transaction. We can then wait maybe 1 minute or so until we think the transaction is going to be included in a block, and then we can retrieve that transaction and make the same checks as before. Alright, so let's get coding. I'm going to create a new file, Dutch transaction, checker2.js. No. Alright. Same thing as before, we need Web3 first of all. So const Web3 equals required Web3. Right. Then let's create our class, transaction checker, And in this class, we're gonna need 4 properties. So we have Web3, which will be the same as last time, just a HTTP provider given us by Infura. And then we also need Web3 WebSockets. Since the subscription API is only available to the WebSockets provider of Infura and not to the HTTP provider. Then we have account, same as last time, and then the subscription. Alright, let's create our constructor with these same parameters as before, so project ID and account. And now we're gonna have to create 2 Web3 instances. So Web3 WebSockets first of all. It's gonna be a new Web3, and instead of a normal provider, we'll use the WebSockets providers. WebSockets. Alright, so this is the URL. Rinkeby again on the testnet .infura.io/WebSockets/v3/ and then concatenate that with, oh, if I can type, the project ID. Alright, and then the normal Web3 instance, new Web3 providers.http provider https/rinkeby rinkeby.infura.io/v3/plus project ID. Alright. Oh yeah, and then the account. So this .account equals account.to lowercase. Like that. Oops. This .account. Okay, and the first method of our class is going to be subscribe, which will subscribe us to a topic of choice. So topic as a parameter. This .subscription equals this .web3, and then we need the WebSockets.eat.subscribe. Yeah, so this is basically the way you subscribe to a topic, and it returns a subscription. So that's where we're gonna store it. We need as a first parameter the topic, and then the second parameter is gonna be a callback. So error or result. And if we have an error, we'll just console.error that error. Okay, so the subscription is now a an object that emits events, which we can then use in the second method, which is going to be called watch transactions. No parameters. Alright, we'll just do some logging, so console.log watching all pending transactions. Good. And yeah, so every time a data event happens, our subscription will return a transaction hash of a pending transaction. So this is what we want to do. So this .subscription .on data will have a callback that takes in a transaction hash. And now we want to wait a given time so that we can until the transaction is included in a block, so that we can then retrieve the transaction like we did in the previous script. So we're going to use the set timeout function. We want this to be async, so we can use a wait again. Set timeout, and for error handling, since this is a little different in async await, we'll use a try and a catch block. So let transaction equals await this .web3.eat.get transaction. We're now using the HTTP provider again to just give us back a transaction object. Then we'll do some checks. So if transaction is not no, we'll just do some logging. So console.log transaction.from. This will print out the sender address of each transaction we retrieve. And then we want to check if the account that we're looking for is the receiver. So transaction.to.to lowercase. Now we're basically doing exactly what we did in the last script. And then we'll also do some logging. So console.log address equals transaction.from value equals this.web3.utils.from way transaction.value to ether, and then again a timestamp. Great. Oh yeah, and then we have to catch any errors. Just console.log them, console.error. And then finally we have to set the interval. Let's start with 1 minute. I'm gonna close this for a second. Okay, now we can again create the instance. So let transaction checker equals new transaction checker process viewer ID and the account. Let me copy that first. Okay. And first we need to subscribe to a given topic. So the topic is called ending transactions as a string. And then we'll start watching transactions. Alright, let's test that out. You can already guess that this is a little less intensive for both the network and the resources, because a publisher and a subscriber structure isn't like constantly, we're not constantly making HTTP requests to the network. Let's run this. So transaction checker 2, and now we're gonna have to wait a minute because of the timeout function. I'm just gonna skip ahead. Alright, so as you can see, it's starting to log all of the transactions. Yeah, okay, this can happen sometimes. Now, of course, there's the possibility that you miss that some transaction, if you, for example, have a low gas fee included to your transaction, is not going to be confirmed in like a minute, but maybe you can do like 5 minutes, so 5 times this, and then every average feed transaction is probably, yeah, actually most definitely gonna be included, unless there's some kind of huge network congestions or something. But so as you can see, this script, in my opinion, is a lot better. It might be a little more complex, but actually I think it's quite elegant with the publisher and the subscriber method. Right, now it's time to put our scripts to the test. I'm gonna run them both. And then I'm going to send a transaction on the Rinkeby test network to the account we are monitoring at the moment, which is my first account. So 0.05, that'll do. I'm gonna send it. And hopefully, so on the first script, we should see the transaction pretty quick, if we don't accidentally skip over a block, which can happen. And then the next one is going to be after a minute. Alright, so here is the first one. So the value was indeed 0.005. And let's wait for this one. Yeah, so that worked as well. Alright, great. Now if you have any questions or something, you feel free to leave a comment describing your question. Also, I will be putting these scripts out on GitHub if any of you just want to copy the code, which is fine as well. And yeah, thanks for watching. Leave a like if you enjoyed it, and see you guys in the next video.